Hello, my friends. This recording will be for the Algebra 1B final review. So first we're going to go over the exponent rules that you did in the polynomials section. And you have some of the rules here on the exam for you, but you have to know how to apply them. So find the product, that means we're multiplying. So that means those big numbers, the coefficients, actually still multiply. So 4 times 2 is 8, but then we use our exponent rule. 3 plus 2 is 5. So just remember the big numbers, the coefficients, do not behave the same way as the exponents. Number 2, same process. 5 times 3, 15. Need that base, so I still have the x, and then 3 plus 6 is 9. Now we're going to look at quotient rule. So for quotient rule, we subtract exponents and we divide the coefficients. So 12 divided by 3 is 4. And then we're subtracting the exponents. Remember, if it doesn't have an exponent, but that variable is there, that it means it's the first power. So it's like these two have little ones as their exponents. So 3 minus 1 makes this m squared, and 3 minus 1 makes this also n squared. And for number 4, 14 divided by 2 is 7. And then the x's, subtract the exponents, would just be 1. If you want to write the 1 for first power, you can, but usually you won't see that. It's not wrong if you write it, but usually you'll just see x there. And then 4 minus 2 is 2. So you're dividing the coefficients and subtracting the exponents. And this is not meant to be an 11. That's just supposed to be a 1. I think my finger just drug a little heavy there. All right, hopefully so far you're feeling good about things. And then with polynomials, these are all considered simplifying, but this first one is addition. So this is just simply combining like terms, right? So for adding and subtracting, we're combining like terms. So the 3x and the 6x, 9x, the 2y and the negative 5y, negative 3y. So be sure that you consider that sign in the middle to be a part of that second term. In the next one, because we have a negative in the middle, this is considered subtraction. And typically, what I instruct people to do is think of it as you're distributing a -1, but what's going to happen is it's going to change every sign in the second set of parentheses. So personally, I like to rewrite them. When it's this small, it's kind of hard to just change it inside the parenthesis. And there's my squared. And then we put our like terms together. But remember, it has to be same variable and same exponent. So the 5k cubed and the 3k cubed, 8k cubed. And then the negative, put that negative there with it instead of up here, since I ran myself out of space. The negative 9k squared is the only squared term. So it's just going to stay negative 9k squared and then minus 2k. Oh, minus 2k, sorry, this is going to go, my apologies. I am trying to make this the day before I leave. 5k and minus 2k make plus 3k. All right. Your teacher should have a key also, so you can check, but hopefully this helps you understand. Next, we're going to multiply. That means we're going to distribute. So we're going to take this 2x times the 4x squared makes 8x cubed. 2x times negative 2x, negative 4x squared. 2x times 6 plus 12x. And then it is the 3's turn, and I'm going to do 3 times 4x squared. I like to put it in a second row, and I'll line it up with like terms. So I just scoot it over one, and then my x squareds are lined up. 3 times negative 2x, negative 6x, and 3 times 6 plus 18. And now we're just going to combine like terms, and they're in nice columns together. So 8x cubed plus 8x squared plus 6x plus 18. So notice that I have to, even though I say I'm adding them together, adding the two rows, I have to pay attention to the signs. So negative 4, positive 12, actually subtract. Same with the positive 12 and the negative 6. The next one is divide. So think of that 6x as being under every part, and then doing division, doing quotient rule like you did up top. So 12 divided by 6, actually dividing those coefficients, and then take 1 off of each of the exponents. So 2x squared, 18 divided by 6, 3, 1 minus 1, or 2 minus 1, 3x, and then 30 divided by 6 is 5, no extra x, so just plus 5. If initially you have 3 terms in the numerator, or what's being divided, right, then you're going to have 3 terms in your answer. Hey, page 1 is done. Now we move, that was like the first unit test. Now we're moving on to factoring. And so your factoring sheet, some of you might be able to get along without it, but some of you that is definitely a friend. So we know the numbers that multiply to be 28 and add to be 11. So I look at my sheet, 1 and 28, nope. 2 and 14, nope. How about 4 and 7? So 2 sets of parentheses. We know each one gets an X. We know that their signs are the same because the 28 is positive and they add up to a positive, so they are both plus. Doesn't matter which one you put the 7 and which one the 4. The order of those parentheses is not important. Now remember here, this is when we're using our asterisk. There are other methods, but what you learned during this class was to use this. So 7 times negative 6, so A times C goes up here at the top, so negative 42, and then it adds up to 11. And then we're going to write 7p, not p squared, just p, on each side. And then we still have to come up with our magical 2 numbers that multiply to be negative 42. It's negative, so I know the signs are opposite. I like to think of that because then it helps me know that the number parts subtract to make the 11. So I look at my list, 1 and 42, that would make 41. No. 2 and 21, that would make 19. No. 3 and 14. Very interesting. 3 and 14 would subtract to make 11. The 14 has to go with the plus sign because we want a positive 11. So and when they're different signs, the bigger number has to match the sign of the middle. Now, last step from our asterisk is to reduce. Sometimes both sides reduce. In this case, only one side reduces. So on the left side, I see that I could divide these both by 7. Whatever you do to on the top, you got to do to the bottom. And that gives me P plus 2. So 7 divided by 7 is just 1. So 1P or just P plus, and then 14 divided by 7 is 2. And then the other one does not need to reduce. Write that down here so you can see it a little better since I kind of wrote it right into my asterisk. Remember, if you want to check your answer, you could distribute it out to make sure that you come back up with the original problem. You can do that for all factoring questions. Because factoring is the opposite operation. We're writing it as a multiplication problem. Okay, and we got a nice hint here that these are difference of squares. We also know they're difference of squares because they have 2 parts. They are both perfect squares, and there is a minus in the middle. So 2 sets of parentheses, and then we're doing the square root. So the square root of 25x squared would be 5 and x. They each get a 5x. Then we're going to do the square root of 16y squared. So the square root of 16 is 4, but it also has y squared, so they each get a y. And then we know for difference of squares, this is when 1 is plus and 1 is minus. And if you check it by multiplying it out, your 2 middle parts cancel out. And that's why there is no middle. It only has 2 terms. Okay, so try the same process on number 12. You can pause me, see if you get it right. This time, we only have, sorry, my plus sign looks a little wonky there. This time we only have one variable. So the square root of 9, just 3 and negative 3. We don't need a y with that because the beginning didn't have a y. And the next one is factoring by grouping. So grouping, even if it didn't tell us it was grouping, we know it's grouping because we see 4 terms, so commonly that's what we should be looking for. So I'm going to put the first 2 together and the last 2 together. And then I look for GCF of each part. So when I look at GCF for the first 2, 12 and 16, and I could look on my factor chart. Remember, you want the greatest common factor, so they can be divided by 2, but that's not the greatest. So 4, and then they have some m's in common. Go with the lowest exponent that they have, which is 2. So then to find what's inside the parentheses, we're dividing both of them by 4m squared. So 12 divided by 4 is 3, 1 extra m. 16 divided by 4 is 4, and no extra m's. So just 3m plus 4. Then I look at the second pair. Because that third one is a negative 15m, what I pull out, my GCF needs to be negative. What do 15 and 20 have in common? 5. So we're going to divide that by negative 5 to see what's inside. And that gives me positive 3m, and then negative 20 divided by negative 5 plus 4. At this point, my parentheses should match. If my parentheses don't match, don't try to force it. You need to go back and figure out why. It may be because you have a sign wrong, or it could be because you didn't take out the GCF. You just took out a common factor, but not the largest one. Pull together what's on the outsides, and then what you had written twice now is only required to be written once. Okay, let's try the same thing. Put them in pairs. Be careful that you don't cover up that minus with that 6. The first two have a 5x squared in common. When I divide by that, I get 2x plus 1. So don't think like, oh, it just cancels out. You need the plus 1. And then for the second part, negative 6. So it's negative, and then 6 and 3 have a 3 in common. And when I divide both of those terms by negative 3, I get 2x plus 1. I've run myself right off the side of the page. 1. Okay. Sorry about this. I think I'm an optimist. I think I have room, but I don't have room. Now pull together what's on the outside, put it in some parentheses, and the one that was repeated now only needs to be written once. And remember, for both of these, if you distribute it out, you're going to see your original. If I did 4m squared times 3m, 12, this is a check. This is not something you have to do, but if you want to make sure you're right, and then 4m squared times 4, and then negative 5 times 3m, and negative 5 times 4. And that matches what I started with. So you can distribute to check your answers. When the original was a trinomial, you might have a combination that you have to combine like terms in the middle, but when it's grouping, you won't even have to combine the like terms. It will just, there are all the 4 your terms. All right, so that's factoring, and then simplifying the radicals. So we want to try to remove perfect square factors. So for instance, I liked it personally, I think of the 8 and the 6 and the exponent separately. So I think of this and this kind of separately. So for the 8, I want to think, what is the largest perfect square that divides into 8 or is a factor of 8? You could even use your factor chart, which is 4. So this is the same as 4 times 2. 4 is a perfect square, so it can send a 2 to the outside, but this other 2, he is stuck. And then x to the 6th, for the exponent, divide the exponent by 2. So 6 divided by 2 means that that is x to the 3rd. Now, so that we don't get mixed up and think that x to the 3rd is under the radical, he needs to be written with the 2 and then the radical part at the end. Now, you may not need to show all those steps, but I'm just trying to show you what goes through my mind. So this one has a negative 8 on the outside. That negative 8 is going to multiply with any numbers that I send to the outside. So 48 and r to the 3rd. So 48, I look at my perfect squares. 36 doesn't divide into 48. 25 doesn't, but 16 does. So this is 16 times 3. And 16 can send a 4 to the outside. So I have that negative 8. I'm sending a 4 out. There's a 3 trapped, right? He's not a perfect square. And then for my r's, 3 divided by 2, 1 time, but there's 1 r left under. Now, everything that's outside needs to go together. So these are going to go together, negative 32r. And then these get written under the same radical, 3r. Okay, next up we have some radical equations. So first off, you have to isolate the radical. Then you're going to square both sides. Then you're going to solve, like normal solve. All right, so when I square both sides, because that radical is already by itself, I get x equal 25. And is it true the square root of x is 25? Yes, that's true. Number 18, first we're going to get the radical by itself, so I'm going to add 10. So now I have -2 plus 10 makes 8. Then I'm going to square both sides to get rid of the radical. So I have r minus 1 is 64. Now I get the variable by itself. So now I'm going to add 1, and r is equal to 65. And sure enough, if I plug it in, that would be the square root of 65 minus 1, which is 64, which would make 8, and 8 subtract 10 is -2. Okay, so next up, here we go. That is touching the radical, so it's currently multiplying times the radical. So to get rid of it, we need to divide. So now we have square root of -6 minus 6x is equal to +6. Radical is isolated, square both sides, which means on the side with the radical, it just is free of the radical now. It's no longer under. On the other side, I actually have to square it. And then in this case, now we have a two-step equation. We're going to add 6. And then we're going to divide by -6. And if I check it, if I put -7 in here, then I'd have -6. -6 times -7 plus 42, which would make 36. And the square root of 36 is 6. And -4 times 6 does equal -24. Okay. So as we talked about, we really should check because sometimes it's extraneous. It's not something you have to show me, but if you give an extraneous answer as one of your solutions, then you'll lose points. All right, number 20 looks worse, but it's actually in some ways easier because it's already isolated. So we're going to square both sides. That's going to give us 3p minus 6 is equal to 2p minus 3. They're both just free of the radical. And now we just have an equation with variables on both sides. So get those variables on the same side. And P is 3. If we put 3 in both sides, 3 times 3 is 9. So 9 minus 6, that's the square root of 3. Doesn't have to be something that comes out pretty. And then 2 times 3 is 6. And 6 minus 3 is also 3. The square root of 3 equals the square root of 3. It works. It doesn't have to be a perfect square under there. Okay, now we're going to look, these are quadratics, and you see the word factoring, but now we're solving by factoring. And first thing we have to remember is it has to be set equal to 0 first before you try to factor. So before you try to do too much, pardon me, you need to make sure that it's set equal to 0. And so in this case, it does not equal 0, it equals 4. So we're going to have to move that 4 over so that we can make that a 0 on that side. And of course, if I'm going to do it there, I got to do it on the other side. Just slide it right there under the 28 because that's what it can combine with. Now we have 4b squared minus 8b. That part's not changing. But now instead of negative 28, we have negative 32 is equal to 0. So now that we've got it equal to 0, now we can start factoring. So we should always, always, always look for GCF first. If you find yourself multiplying A times C and getting something that's off your factor chart, it's probably because you should have done GCF first. So GCF first, we can divide all of these numbers by 4. Every one of them could be divided by 4. That's their common factor. So then we would have 4 on the outside, b squared minus 2b minus 8. So our factoring just got a lot easier because now we just need to think about what multiplies to be negative 8 and adds up to be negative 2. So I have b minus 4 and b plus 2. At that point, we have factored, but remember, those aren't our solutions. And our 4 for our GCF is still part of our factors. So when things multiply together to give 0, one of them has to be 0. But 4 can never equal 0. So we don't need to worry about the 4. If it was an x out there, we would have a possibility that 0 could be one of the solutions. So b minus 4 equals 0, or b plus 2 is equal to 0. And we just solved those two equations. In this case, they're really small equations, and it turns out that our solutions are simply the opposite signs from our factors, from what we saw in our factor. So those are my two solutions, positive 4 and negative 2. So in my factors, the negative is bigger, but in my solution, because I had to add 4, it's positive 4 for the solution. All right, so here we're going to use quadratic formula. So We have it right there, so we don't have to worry about memorizing it. So identify your A, B, and C. We're not factoring here. We're going to use quadratic formula. So I'm going to write those over to the side first. Sorry about that. Trying to write that. So we know A, B, and C needs to make sure that it's always in standard form, that the x squared is first. So in this case, A is 5, B is -10, and C is -15. And then x is equal to negative B. So negative -10, which is going to turn out to be +10. So it's like saying it's the opposite of B. Plus or minus, and then we square B, so -10 squared. If you're going to use a calculator, please put it in parentheses or you're going to get the wrong sign. -4 times A, which is 5, times C, which is -15. And then all of that divided by 2 times A. So right now, I have just plugged A, B, and C into the formula. And I'm going to start simplifying some things. So first off, -10 just makes 10. And maybe you just think opposite of -10 is 10 and you just wrote down 10 to start with. And then underneath the radical, -10 squared is +100. Anything squared is positive, right? Because signs are the same. And then -4 times 5 times -15. I see two negatives, so I know this is going to turn out to be plus. And then 20 times 15, 300. And you could use a calculator, and this would be a little shorter, but I'm just mentally doing some of this math. 2 times 5 is 10. So 10 plus minus. This is the square root of 400 over 10. At this point, if that is a perfect square, which 400 is, then we're going to split things into two situations, one for the plus and one for the minus. And then our square root will be out because it's a whole number. So then we're going to say x is equal to 10 plus square root of 400 is 20, divide by 10. And then my other solution is that x is equal to 10 minus 20, divide by 10. 10 plus 20 is 30, and 30 divided by 10 is 3. If you happen to just try to do it all in the calculator without writing the 30 over 10, be sure that you're hitting equal before you divide by 10, or the calculator thinks you only want to divide the 20 by 10, not the whole thing. And then down here, this makes -10 divided by 10. So we get x is equal to -1. So we have two solutions. So x is 3 and x is -1. You could be fancy and put those in set notation or just leave them like that. But there are two solutions. Okay, in the next part, we're going to be graphing this quadratic equation. So first off, to graph this, we know it's going to be a parabola, but we need to figure out what is going to be in our table. So first we do x equals negative b over 2a to find our axis of symmetry. So here a is 1 and b is 4. C is 0, but we don't need C for this anyway. So x equal negative 4 over 2 times 1. You can just leave it here, it's fine. Thank you. So negative 4 divided by 2 is negative 2. So this is my axis of symmetry. That's going to help me make a good graph. So now I'm going to go over to my graph. I'm going to find negative 2 on the x-axis. And I'm going to make a vertical line going straight up and down. So my vertex, my axis of symmetry always goes through the vertex. So I know I want to use negative 2 as one of my x's. And then what I would recommend is add 1 to that and make negative 1 and add another one and make 0. And we're going to use 3 points and then we're going to mirror those 3 points. So you would not necessarily have to fill out the whole table because you're going to use mirroring or the symmetry. So now we plug in negative 2 to find the rest of our vertex. So then negative 2 replaces the x. So that gives me 4 minus 8 which is negative 4. So negative 2, negative 4 is here. Then we're going to do the same thing, but with negative 1. Negative 1 squared plus 4 times negative 1. So that's 1 minus 4. That's equals to negative 3. So negative 1, so 1 to the left of the origin, and then down 3. So that's here. Should not be far from your vertex. And then we're going to do 0. Well, 0 squared plus 4 times 0, that's a whole lot of zeros, right? 0 plus 0 is just 0. So that's going to be right here at the origin. Now, we're going to use mirroring or the idea of the axis of symmetry. So as like it's reflecting across. So I know if there is a point 1 space to the right of the axis of symmetry, there's going to be another point over here because that axis of symmetry is as if we folded it in half. And if there's 2 points to the right, or there's a point 2 spaces to the right, there's 1, 2 spaces to the left. So I use that, but I know that the parabola will be symmetrical to find the other points. And then just connect those. It's going to go up pretty sharply. There we go. It should make a U shape, a parabola. All right, so here with this application problem, if we want the maximum height, that means like That's the y of the vertex. But to find the y of the vertex, first I have to find the x of the vertex if I'm going from an equation. And in this case, when I say x, it's the same as t. So this would be negative 12 over 2 times negative 3. So negative 12 divided by negative 6. Positive 2. So it reaches its maximum height at 2 seconds, and then we have to put that 2 in for the t's. All right, so 2 squared is 4, negative 3 times 4, negative 12. 12 times 2 is 24, plus 15. So negative 12 and a plus 15, or plus 15 and plus 24 is going to be 27. And it's the height, so it is meters. We want it to be, use our language skills, we could say the ball's maximum height is 27 meters. And that would be delightful if you wrote a sentence to answer that. The next part, still looking at that same situation, but now we're talking about when does the ball hit the ground? So I want you to keep in mind that hitting the ground means it's equal to 0. So we're saying 0 equals negative 3t squared plus 12t plus 15. And if for the purpose of this you want it to use x's, because maybe your t's look like your plus signs, it would be okay. So hitting the ground means the height is 0. Since the height is 0, we want to try to, we need to solve this, but it has a second power. So we're going to try to factor. If we could not factor, we would have to use quadratic formula, but I'm hopeful that we're going to be able to factor. So let's try dividing by this first coefficient, and we want that squared to be positive. So I'm going to divide everything by negative 3. So now I have negative 3, and then inside my parentheses, t squared minus 4t minus 5. And then I want to see, can I factor this trinomial? Do I have two numbers that would multiply to be negative 5 and add up to be negative 4? Thankfully, the answer is yes, negative 5 and positive 1. So I have t minus 5 and t plus 1. And then when I solve, I get 5 and I get negative 1. But this is the time when it hits the ground. And since it's the time when it hits the ground, this means negative numbers don't make sense. So no time travel. So 5 seconds. Okay, great job. Good luck.